Please, we would like you to give us a brief introduction of who you are and what you do at the University of Cape Coast.
Okay, thank you very much. I thought you already have my bio, so you rather introduce me. But if you give it to me, no problem, I'll do it. It's like the ball is in my court, and I can't allow it to score and to become like Ghana Black Star. Okay, so I'm Dr. Patrick Essien. I have PhD in space geophysics, and my interest or my research interest is in upper atmosphere as well as the neutral atmosphere, because the sun affects the upper atmosphere, or it influences the upper atmosphere, as well as the lower atmosphere. It also influences the upper atmosphere, depending on the condition. So actually, my specific interest is what happens in the ionic layer in the upper atmosphere called ionosphere. This area has some kind of irregularities that can cause a signal delay as far as satellite signal and the communication signal is concerned, or navigation signals like GPS, GLONASS, and then Galileo. So in the University of Cape Coast, I'm a lecturer at physics department, specifically atmospheric meteorology and atmospheric program here in the University of Cape Coast, and also a research scientist at Meteorology and Atmospheric Research Lab. In this lab, these are some of the few research that we are doing. First and foremost, we have an instrument from Japan. We are collaborating with Japan research institutions, space research institution, and the other university to study the irregularities in the upper atmosphere using an instrument called All-Sky Imager, where we observe equatorial plasma bubbles. These are the bubbles which generated in the equatorial region and propagate along the magnetic field lines, or the magnetic equator. Okay. We are also expecting another instrument from Michigan State University, also to study the GPS signals. That is, the problems, the irregularities imposed on the GPS signals, or the fluctuations, what we call scintillation, and then other stuffs. Recently, we are starting another project that is studying the emission sources and sinks of methane. That is methane gas. Methane is one of the hydrocarbon gas in the lower atmosphere. It's a greenhouse gases which accumulate the heat in the lower atmosphere, leading to increase in global temperature and what we call the global warming, okay, the climate change issue. So we are developing that also research, and I think not long ago it will take part in the University of Cape Coast. Aside that, I'm also collaborating with a friend who is studying the rainfall patterns and then other necessary research. So actually, we have a lot of things doing in University of Cape Coast, but let me say a few. So it's okay.
Of course. I mean, there are lots going on, and there are a lot of things that you are involved in.
Yeah.
So it's good that you even did justice to it, because I mean, the introduction has been great.
Thank you.
That is great. Okay, so our topic for today is the purpose of satellite technology in the outer space. First of all, I would like you to brief us a bit on what satellite technology is and what is its role in the outer space.
Thank you very much. So when we talk about the satellite, in the days we were spending more time talking about artificial satellite and a natural satellite. But right now we are into more of artificial satellite, because that is answering most of our problems, technological problems in the world today. In the days we used to talk about a natural satellite, that is anybody that is rotating around or moving around a particular heavy celestial body, but that gave us also the foundation to produce the artificial satellites. When you talk about Galileo, what Galileo was able to develop telescope to observe the sun as the center of our universe, what we call heliocentrism, and then all other celestial bodies are rotating around it. There came to an idea that no, if the Earth is rotating around the sun and it's not moving away, and all the other planets are also in their orbit, then there is a scenario. It means, one, the force of gravity that exists between the sun and those bodies are strong. And another thing is the reason why they are not moving away. Okay, if that is the case, then if artificially we produce any body, also put it on one of these celestial body, it will, the force of gravity of that body and then the artificial body that we produce, which is now we call a satellite, will also establish this gravitational, universal gravitational force. And it means the satellite will not just move away, but it will rotate. It also means if you put any sensor, be it camera or anything that can give us a particular information, then it's possible it will have a wider range of view, okay? And it also have a wider range to transmit the signals. So there came the satellite, artificial satellite that we are talking about.
Okay.
When you talk about the outer space, let me be brief about here. We have what we call the airspace and then the outer space. Normally, the airspace is normally the lower and then middle atmosphere. If you look at the layers of the Earth atmosphere, you have the troposphere where weather exists and all the climate change aspect takes place. And then we also have the stratosphere where ozone layer exists. All these places, we call it airspace, even including the mesosphere. When we, after about 100 kilometers going, then we are getting to what we call the outer space, where the force of gravity is almost what? The gravitational force is almost zero. The force of gravity is almost zero, okay? So at these places, we believe that when we hang a satellite there, the Earth cannot pull it towards itself. So when you go to exosphere, then you are going to the outer space. So the outer space is where the normal gases or the air we've been seeing here do not exist. And also the force of gravity between those places and then Earth is almost zero. So when you hang a satellite there, it will be there forever. And depending upon the mission of your satellite, this satellite can be there to perform whatever you ask it to perform, especially in this technological dispensation.
Okay. All right. With you talking about artificial satellites, we want to find out how has satellite technology evolved from the launch of the first satellite, which we know as Sputnik? How has it evolved to this day?
Okay, thank you very much. So we will first say thank you to those who were able to produce the first satellite. That is the Russians, the then Soviet Union.
Soviet Union.
Maybe if you to go into critically, you know that the aim of producing that satellite by then is not the same as today, because the world has really advanced. The evolution has been great. So the first satellite, that is Sputnik, was produced by Soviet Union in 1957. I think the same year Ghana had independence. Yeah, so by then, what we call the space age began. And it became like a technology war between the United States. So not long ago, I think United States in 1960 also produced a satellite, Explorer and I think Vanguard or so. Okay, but the Russian satellite Sputnik was actually for so many reasons, including political reasons. Okay, yeah, but after that, United States also come out with a satellite, like I mentioned, Explorer, and then other things, which also had other missions, like Earth observation satellite and the communication satellite, and then other things. In 1970s, we started seeing the gestational communication satellite, also from US. So actually, Russia started, but when United States came in, they were doubling steps, and you know this during this Cold War, they were doubling steps, showing the technological powers. Even in 80s, that is, I said between 70s to 80s, that is the gestational satellite, communication satellite started coming, and then others, where we use satellite for telecommunication, and then others, you know. In 80s, there came what we call navigation satellite. Okay, I think United States produced the navigating satellite, what we call GPS. The GPS is for United States technology. Okay, then Russia also came again to produce what we call GLONASS. That is their navigation satellite, yeah, but it's a little different in terms of constellation and frequency band and other things, a little different from GPS. I will not go into detail with that.
Yeah.
It's detailed because my PhD or research is on the GLONASS and then the GPS. Then the European Space Agency also came in with what we call Galileo. They name it after the one of the exclusive and, I mean, should I say perfect satellite scientist that, you know, was originally or was involved in the coming of the artificial satellite. So they call it Galileo. Japan, India, and the other groups are also producing satellites, navigation satellite. China also came in not long ago with a navigation system called Badu. Until recently, we have many satellites that involve in internet providing, and then even early 2000 or maybe 90s coming, we started even seeing what we call CubeSat and then CanSat, whereby a system can be put in just a can and then put it in the outer space to give us information about what we need. And also in the millennium, there came a laboratory, a whole laboratory in the outer space, what we call International Space Station. This is not actually belongs to any particular country, but a couple of countries that came together to produce this. So I think when you talk about satellite evolution since 1957, when Sputnik came to the scene or the limelight, I think it has really been interesting. It has been improved. And it will be a possible, one of the possible ways in which you and I are even communicating, you know, how far you've gone.
Okay. Okay. Yeah, so I wanted to find out, aside this satellite helping us in communication, what are some of the primary functions and applications of satellite in the outer space? What are some of the primary functions?
Okay, thank you very much. So before you launch a satellite, we need, first and foremost, you have to prepare what you call mission statements.
Okay.
So it's like a car. If you want to produce a car, first and foremost, you need to come out with a blueprint of what the car is exactly going to do. So we have, like I said, we have Earth observation satellite. If you say Earth observation satellite, it means that satellite is observing what? The Earth. Maybe it's studying the forest zones of the Earth. Maybe it's studying the carbon dioxide emission of the Earth. Maybe it is observing the rainfall pattern or variables of the Earth, okay, or in the troposphere. Maybe it is studying the ozone, okay, the concentration of ozone in the troposphere. Maybe it is studying the ionospheric electron density. If you look at a satellite like what you call ICON and then others, maybe it is studying the temperature profile of the atmosphere, like cosmic satellite and then other things. So every satellite has its function. If you consider satellite like solar Parker probe, it is studying the sun, okay, and so on and so forth. So before a satellite will launch into outer space, it has so many things depending upon the mission. Then you develop the satellite. So actually the mission statement or the blueprint of the satellite, why you want to produce those satellites, should even come out before funding will be awarded for that satellite. For example, in Ghana, all nations university launch a satellite, a small satellite, to study the Galamsey zones, the illegal mining zones, and then other things. So it means that satellite, the sensor around the satellite should be a camera, okay, which will be able to capture all this, what do you call it, information. Or even if it capture it not in picture form, it should capture it in a way that we can process the data to get the real pictures of what is exactly happening. Like International Space Station is a laboratory. Of course, it's also a satellite. It's a laboratory. So it has its functions, okay, that is doing. And apart from even launching a satellite to outer space, you can launch a satellite to other planets. like Mars rover.
Yeah.
Mars rover is in Mars, roaming around the Mars. It has its, what do you call it, function. We also have another satellite produced by another state called, I think, Galileo, that went to Jupiter to study the properties of what exists in the Jupiter, and so on and so forth. So each and every satellite has its mission and what is due. Because you are using internet, let me say one, like Starlink, it produces a satellite, right? It produces internet signals for all of us. Yeah, thank you.
Yeah. Okay. What some of these functions mentioned, I want us to bring it a bit closer to us in terms of satellites' contribution to weather and climate. So how do they contribute to weather forecasting and climate and monitoring of climate change?
Okay, thank you very much. So every sensor around the satellite is prepared in such a way that it takes a particular process or a particular function that is going on in the atmosphere, and it meets it as such, because all the chemical components that we see in the atmosphere, all the emissions, they emit a certain radiation, and all these emissions exist within the electromagnetic spectrum. So when a satellite is made, they put sensors to be able to take a particular variable, because we talk about the climate, and all we know that the climate change we talk about normally take place within our lower atmosphere. But all the satellites that observe the climate processes, like the rainfall, like the temperature, like the concentration of greenhouse gases, like the aerosols, like lightning, and then all those things, they all sit in the outer space and then observe it from a distance, what you call the remote sensing. Although sometimes you need ground-based instrument to take some data for validation or for accuracy, but all the satellites sit in the top there, so with sensor and other what do you call it, gadget that help us to take the data from the troposphere. It's equally like taking a picture from a distance. Okay, if you want to take a picture of something, depending upon the wavelength of the camera, okay, yeah, it can take it from a distance or it can take it from a closer. But like I said, if you take it from a closer, you know the accuracy or the resolution is clear. Taking it from a distance, that is why mostly we mount weather stations and other stations to measure other variables, especially within the troposphere. Not depending only on the satellite, the information from the satellite. Let me come in with this. When I came for interview at the University of Cape Coast, one professor asked me, what at all, what do you call it, interests me to study space was climate change. The issue of climate change is within the lower atmosphere, the blah, 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 you know, those of, but these questions are normally asked in developing countries, excuse me to say, you know, but I only said that, okay, you can go through all the satellites, taking the data related to climate change, and then other aspects like ozone in the stratosphere and then others, and all the other things in our atmosphere that affect us. Even look at the satellite that is studying our water bodies, that is the oil in our seas, the satellite that is studying the vegetations, and then others. Those satellites, where are they? Are they in lower atmosphere or they are in outer space? So one thing is that if somebody does not study outer space, how then are we going to understand the space environment for us to one day produce a satellite and then put it there? It will not take a miracle. It will take a thorough research for us to know the space environment, to be able to advise a material scientist to select a requisite material that can resist all the problems in those environments, okay, for us to achieve our aim or the mission set for their particular objective. Thank you.
You're welcome, sir. Okay, so you made mention of remote sensing. So I would like to find out whether remote sensing satellites, how are they contributing to the environmental monitoring and growth?
Interesting. Okay, so should I say most of the satellite, all the satellite that observe in the lower atmosphere, middle atmosphere, they are all remote sensing approach because they observe from the distance. It is only in the ionosphere at the moment that we have satellite like ICON and also SINOF passing through ionosphere, even that one upper ionosphere, because if it comes closer, the Earth gravitational pull will pull it down. Yeah, so most of the global research that shows the trend of the climate or the change of our weather pattern and then other things, we use what do you call it, satellites to study it. And this gives us information, because without that, we wouldn't know what is going on, especially if you are to even mount instruments across Ghana or maybe a place like Amazon forest. You can mount instrument everywhere, though some of the instrument, if it's the instrument is sitting in UCC, it will have influence as far as maybe salt pond, because the environmental situation or the ecosystem from here to salt pond might not be all that different, depending upon the variable that you are taking. And also you attest the fact that we have coastal environment, we have forestry zones, even we have the desert and then other places. At all these places, the conditions there are hot, are different. But if we use satellite data, it gives us the global picture, okay, of what is exactly going on globally. So I think the satellite information we are getting from satellite are contributing a lot to our understanding about our environment, and then understanding about how the climate is what changing. And without that, models and then other things too cannot what come up, because models depends on the observations and then other things we've done in order to develop models, okay, to suit the trend in which we've been seeing.
Okay. All right. So how do satellites, how do they contribute to disaster management and emergency response capabilities?
Okay, thank you very much. This is interesting. In 2016, I was in the United States, and we were staying first floor. So one day we heard that there was a smoke. We were sensing a smoke coming from upstairs. And we realized that those people staying there were not around. And you know, elsewhere, if you are even staying in somebody in the same apartment, you can only say good morning, hi, then you go your way. You know, nobody cares about anybody. So we didn't have their contact, anybody. So the best you could do is to call fire service. When you call the fire service, within 5 to 10 minutes, you were staying at a point where we have 4 routes, one from here, one from here, one from here. Within 5 minutes, the fire service arrived with their fire engine. We came out and then we saw a whole medical team also parked on the other side. We saw a helicopter roaming in the atmosphere on top of the building. We saw the police service on the other side of the road. And we saw even military also on. It's like within the shortest possible time, it's like we were shocked. Hey, what is happening? So it means when they came, if it was for them to use water from above, they were ready for that. If some people were in there suffering, they would have evacuated them within the shortest. Yeah, it's like they came in with everything. So let's come to the satellite. When we decide to use satellite technology to study disaster management, to manage the disasters and other things, it's just a twinkle of an eye, because when it comes out that there is a particular sensor here sensing that the temperature here has gone high, or the carbon dioxide or carbon monoxide has been very high, it means there's a heavy smoke coming out of that zone, okay? And you know, fire comes out with smoke comes out from fire. So it means within the shortest possible time, this sensor will be able to communicate via satellite and to all the other systems and to all the other stakeholders. So within the shortest possible time, those disasters will be what? Managed. For example, sometimes our market center, there will be fire in our market centers. And even calling the 119 is a problem. Assuming if you have a census in all the market centers or fire-prone zones, if there is any fire, it's relating to temperature, the sensor will sense and it will send the signal via satellite. And wherever they are going to receive those information at a time T and respond to it equally. When it comes to our forest zones, look at the degradation and then other things in our forest zones. If you have a satellite that is studying Ghana forest, there's no need for interministerial committee or, excuse me to say, intercorruption committee to go around to a deep forest before they will know that people are hot, doing what you call afforestation there. No, we can use the satellite to study all our forests. And we will know that, no, whether the forest is degrading or not. There's a tool called GIS, Geographical Information System, where we can use to study all those zones. If you have a satellite data, there's a center in Legon called SEGIS, Center for Information or something remote sensing. They do that. But I can't tell if they are well resourced to do all these kind of things. You know, I don't want to go into that. And I think like it will help, because if you look at the GPS, when you punch Cape Coast, it gives you automatically the geographical and the geographical information about Cape Coast, the latitude and the longitude. And then you can navigate towards Cape Coast, right? Because the GPS is in such a way that 4 satellites sees you at a time, and they're able to give all those information. The same constellation is what they adopted to build Starlink. That is the satellite in constellation. If not that, like in the days we use satellite in geostationary orbits for internet, but now we have satellite in constellation. So if you have to use satellite to manage our disasters, earthquake, whatever, and then whatever you can call it, the rising of the seas, the for sea defense, and then other things, we can use satellite to study everything, and it's going to give us information at every point in time for us to respond to it.
Okay. Talking about satellites in emergency response, I still want us to delve there a little. Do you think Ghana, we can get to the point where satellite will be helping us in emergency response and disaster management processes?
Nana, I will have allowed you to answer this question. Why is it that we can? We can. What is need is I don't want to say it political will, but let me call the leadership will, the will of the leaders. For example, Ghana Space Science and Technology was established in 2012 or so, 2012. Yeah, 2012. By then, I was a teaching assistant in the University of Cape Coast, but because of my interest in space, I went there during the launching, where many people came, and they were having so many plans, apart from the then, is it Ghana Telecom, giving them their astronomical dish, satellite dish, to use for astronomical. They were having so many plans. But things has been slow, but I think it still boils down to the political world or the leadership world, because I was thinking at this time, Ghana Space Science and Technology should have been Ghana Space Agency, to have the autonomy on their own. but it's still under Ghana Atomic Energy. And I also know that for so long a time, they've done Ghana Space Science and Technology Policy. And based on that policy, they could have given the institute autonomy to be agency on their own so that they can expand their tentacles. All nations universities were able to launch CubeSat. Every journey of 1,000 miles begins with a step. When I was doing my PhD, I used to watch YouTube, seeing Apostle Kojo Asafo launching rockets. Whether those rockets was for space purpose or other things, like I told you, Sputnik was launched in a minimal mission, okay? But now you can see what is happening, the evolution. So if you developed it like you could have gotten here, Galaxy Aerospace, I think people have been launching a rocket and then others. So it means we can. When we start from now, we can. A little drops of water always makes a mighty ocean. When computer came first, Pentium 1, it was something else. You can't carry it, Nana. But now, yeah, you can use your phone to even do everything. We are in the world of AI, where I can sit here to command a particular technology to develop everything for me within the twinkle of an eye. So Ghana can. What we need is the leadership. KNUST started doing aerospace engineering long time. They have the brains. We have the brains. Listen, there's nothing like the white people are intelligent than us. It's not true. For them, they have the various institutions, like you started Galaxy Aerospace. By this time, government is already there. Knowing what you are doing, there are systems for you to get the necessary avenues to develop it. Okay, and it's like you to your role in Galaxy is to develop the technology in the country. And you see, even Apostle Kojo Asafo, people have been complaining about the prices of his cars and then other things due to tax. What is happening? What is happening in our country? So the thing is that we need the will of the leadership to develop our space sector, to spend money in our space sector. Nigeria Telecommunication Agency, like we have a NCA, National Communication Authority. They launched the first telecommunication satellite, I think in 2012, 2013, I'm not all that specific, but in 2010, they launched the first satellite called NECOMSAT-1, Nigeria Communication Satellite 1. It got lost, okay? It got lost. If I say it got lost, it means there was a failure in launching, maybe the power system, the communication system, and then other things failed. Then they launched another one, the second one. So Nigeria has a communication satellite. South Africa has so many satellites. Even Azerbaijan has a satellite that is producing internet for part of Africa. Why Ghana we can't? We can do it, but you know, we need the world. If maybe I become the president, I don't want to be like the vice president who keep on promising, but it's like, I can categorically say that I, as a space physics, and then know that space scientist, and then know that the space technology is one of the best way we can use to liberate ourselves from this economic hardship. I know people will say why, but every technology that is on the surface of the earth today depends on the space technology. The navigation of the aeroplane, the navigation of the cars, the navigation of the ships that bring all the things from abroad to this place or send our cocoa and then other things, it depends on the satellite in the space. The communication, the computer that we use, our oil in the seas, we use satellite to study them, do the exploration and then others. Or prospecting, our mineral under the soil or in the soil, we can use satellite to study them to know the amount of mineral that we have in our soil. So during the negotiation table, if we cannot even mine our own minerals from the soil or drill our own oil from the seas, we will know what is there and we will know how we are going to negotiate. So if Ghana is to go into satellite technology, like I promise you, this is not a miracle. Of course, this is not a crusade. This is a scientific discourse. So I wouldn't prophesize, but I can tell you categorically that we can liberate ourselves within the twinkle of an eye. Okay, let me come to this. Now, before your question, look at how much we pay for internet in this country.
Yeah.
Yeah. Let me be a little controversial. It's a criminal issue, man. Because out there, they pay a little for internet. But look at how much we pay for. If we are using iPhone, then you are dead. Because all the apps and then other things are going to take the data off. They should engage all the private organizations into space and then other things. And together we can be able to liberate this country, you know, through space technology and other things. They shouldn't put politicians there, okay? They shouldn't put politicians at NCA and then all those places, okay? Because politicians think about after 4 years what he is going to get. A space physicist or a space scientist or technologist will think differently. At the end of by the end of the day, you should achieve a mission planned. It's different and all together. Okay.
Okay. Okay.
Yeah.
All right. So Akwesi, please, you can go ahead. You can unmute yourself and then you ask your question.
Sorry, guys. It's very early over here. So that's why I have a question. I first got introduced to Starlink, where I'm a network engineer over here, and where I work is like remote areas. So getting internet access to those locations to get paperwork done, connect to servers and stuff is very difficult. So I first introduced the company to Starlink, and we used it once until we got fiber connection. And it's like one of the best things that my boss is like, it has ever happened to them, because it's very consistent. It doesn't go off when the weather is bad and stuff. So with you guys talking about Starlink coming to Ghana, that's what drove my interest to be following you guys and watching your presentations and stuff. So with what Doc said, I have a question. So in case Starlink decide to transmit in Ghana without the consent of the NCA, would that still work since it's coming from space? Because I know they have their own satellite.
Of course, it can work, but also they can detect it. That is one thing. So it's equally like having an FM station in Ghana at the border. Okay, they use what you call directional antenna in such a way that those satellites will not get to, if it's Afrao, Togo. But you know, signal spread. In the basic physics, we say signal travels in a straight line. No, but it's spread. It can spread around an aperture called diffraction and then other things. So in as much as a signal within a particular frequency can be restricted to enter into our country, it's not possible that way, but they can detect. Okay, with high technology, they can detect. And you also know that White House in the United States, when any satellite imagery get there, that place becomes dark. And all these are within the electromagnetic electromagnetic spectrum. So when you use it illegally, they will detect. And you know, that is when they will show you that there are laws, because there's an agency or authority that has to assign a particular frequency, okay, to be used in the country. So that is one thing. Notwithstanding, that doesn't mean if they are restricting the use of the Starlink and then other things is good. It's not good. But like I said, they are restricting because, one, let me be emphatic here. One, I don't have any evidence, but that is the fact. One, they are in bed with those telecommunication companies, because if they allow Starlink to come into Ghana, it means buying of data is going to reduce. So if a day, about Ghana, we are 30 million, if it's about 10,000 people, or even 1 million people buy a data of one city, it means 1 million Ghana city, okay? a month, it is going to be 30 million Ghana cedi. So it means the telecommunication companies are going to lose that, because when Starlink is in Ghana, one company or one institution like US can maybe pay some amount of money to Starlink, and the whole campus, wherever you are, at the time T, you can even go to your bathhouse, you are going to get a signal to use. Though there's what you call multi-path signal, where when the signal hits a building and then other things, but this reflection and then total, is it reflection and total internal reflection, everything works within the satellite. So the frequency will not be deviated. You are going to get the frequency at any point in time, wherever you are. So that is one key thing. I don't know other countries if they are also monopolizing the system like that, not to allow Starlink to operate.
No, it's not even like that. Like even where I live, there's like so many vendors that it will even be shocked that why is that just this area alone? It's like so many internet providers. But the funny thing, they are all making their money. Because it's the choice that you, if I choose to keep you, I'll use your services. You see, but it's a bad thing. I think the government needs to be, it's something that we all need to speak about, because internet services is very, very expensive in Ghana. Like I said, my job is moving fully remote, and I was hoping to even relocate to Ghana and work in Ghana. And I was happy that Starlink was going to start their services. But just this alone is like making me think twice. I don't want to be in an area where I'll be restricted on the internet, because now everything is well connected. These days, even if you're going to buy fuel, you don't even have to put money in. Once you can connect your phone to it, the payment automatically connects to the station, and you can pump gas and do everything. So the future is networking, and the internet is everything. So I think it's something that we Ghanaians need to take it upon our leaders, because they don't see the value of it until when we start doing something about it.
Thank you. You've spoken well. I will organize a symposium for you at the UPSA to come and speak. The thing is that I think like aerospace, you started doing well, but I think you've been in the room for long. Okay, you started these interviews. I think it's a time for you to also come out. Okay, get a camera and then everything, to go to certain places to interview people on camera, so that it will not be on webinar just like that. Put it on Facebook, put it here, organize symposiums. Okay, organize symposiums for people to speak out. Some of us, it's like, that is what we wasted our time studying. Like I said, 2016, I was in the United States. I got a job. That would give me, I think by then, $2,500, $3,000. I was only working on for some hours a week. And I could get this job 2 times, 3 times. I even got a PhD in environmental studies, but I left to study, to do space geophysics, because that was my life, and that is still my life. So if my life would take me to jail or cemetery or dead, no problem. Some of us, you are ready to speak, but it's like the platform should be built for you, because if you Galaxy people start building those platforms for the technocrat, for them to speak like we are doing now, but the thing is, how many people are watching? It is not going to be like the non-usual analysis that he's an NDC or he's an MPP, but it will be like the person is speaking from technocratic point of view, organized by a neutral body. Do you understand? Yeah, so I think you and then other players into space should double up your steps. I will have interview. There's a team from, the guy did astronomy in UK, and the other teams, they are coming to University of Cape Coast here with their cameras and everything, because they want to do live interview. So we need to go further. We need to go further, because listen, like I told you, there are so many things that is being monopolized in Ghana here. And now if we do think that it's only about our economy, but without the technology, the economy has no basis.
Yeah.
That is why economists like Dr. Bawumia can say that we are moving from taxation to production. It will not work without the technology. If you have the technology, everything is going to work. I had an interview with Peace FM, and I told them that If I have my way out, I'll cancel so many subjects in basic schools, like RMG and then all those things. I'll cancel them because I don't know why my daughter, my son should go to school to learn about the date Jesus was born, the number of wives Muhammad married, how many days should I pray? No. Because when you go out there, they don't do this kind of things. They prepare them right from scratch. But the thing is that the people are monopolizing the system. Look at our credit system. I swear, where Kwesi is, you don't need to have money to buy anything. You can have your credit card. You can buy iPhone today and pay it 10 times. Divide it to pay. Ghana, if you need huge amount of money to buy something, you have to go for loan with huge amount of interest. A killer interest. Okay, that by the time you are even dead, even your Insawa cannot pay that interest. Do you understand? Because there are players in the system monopolizing the system. So they will not allow credit system to be developed. Whereby you can hold a credit card and then buy even pure water and pay it tomorrow or ending of the month. Okay, the same thing is up to what is happening in the assign of frequencies. Okay, the FM stations, it's a hell to get a frequency to operate in Ghana. I'm telling you, you need to go through hackers politically, sometimes even spiritually, and then add it before you get there. So the system is built that way. Maybe, like I said, every journey of 1,000 miles begins with a step. We need to start talking about it. We need to do a lot of things, and then in the future, hoping that things will change.
Okay. All right. Mr. Charles Dazi, please, you can go ahead with your question. You can unmute yourself and ask your question or suggestion.
Hi, Dr. Esin Charles. I'm sure we have spoken some time ago. If you remember, please.
Hello.
Hello, Mr. Charles Dazi.
Hear me? Can you hear me?
Hello, Charles. Yeah, we can hear you now.
Can you hear?
Have you gone?
Yes. I was saying, Dr. Esin, good afternoon. I mean, I'm sure you remember me. We've spoken before.
Yeah, Mr. Charles. We've spoken before.
Yeah, me, you, Victor. I'm the engineer at Galaxy.
Yeah, I remember.
Yeah, we had one podcast. It's been a while now.
Yeah.
And we have our group. I think I brought you into our group sometime.
Yeah. Then you dogged me.
No, we didn't dog you. Ikea has always kept in touch, so we are putting things in place. Thank you for your submission as well. Akwesi too did a great submission as well. I'm very interested in the fact that you said Galaxy should start being more popular and letting people know about what we are doing and some of the projects that we are working on. And I believe the team is working hard on it. Ikea and the team are working hard on that. Also, I want to make it understood that I think on the beginning stages, because it's a private entity, sometimes Galaxy wants to be a bit quiet, which I know a lot of people have come hard at me asking, why are we quiet? Why are we not really doing much? Why are we not showing that we are the system and all that? And sometimes we are also scared, as you said. You know how this politics works in the country. It's like there's no regulation for space. I think it was just in July 2023 that there was a space policy that was passed. And I think we are all looking at it to make it better. And Also, my submission is, of course, Starlink is here to stay, hopefully. Obviously, I know Ghanaians are going to shout that it's quite expensive. I think with everything that we're doing, every initial cost is always high because of the hardware that's being used. Because we are launching rockets into low Earth orbit and burning 700,000 gallons of fuel per second. So obviously, in the beginning stage, it's going to be quite expensive. But we believe Elon Musk is a nice person, just as he was giving money to ex-users. I'm sure when the usage becomes high, the prices are going to come down, and then the beginning people are going to enjoy a lot. Maybe they might get free internet for maybe 2-3 months. So we ensure and we encourage everybody to start so that they enjoy the future stuff that are going to come as well. And we hope that Galaxy is always going to be in touch with you most of the time, Dr. Essien. We didn't dog you. I think you dog us, Kaka. But we hope to be in contact, and we hope that you will be privy to most of our experiments that are coming up, hopefully, within a few months to come. As we have set a date for 2030 that we want to see something in orbit. Obviously, there's a lot of work that will be going on the site, and we haven't dog you. We definitely come to you. Okay, the team will come to you. So thanks for your time with Galaxy, and we'll obviously be keeping in touch as time goes on. Thank you.
Okay, AC, thank you. So Charles, it's good to hear from you once again. You said something like Starlink, people will complain that it's inexpensive. I think it's not expensive. It depends upon the way you are going to do the business. I think for you to be assigned a particular band within the spectrum in which Starlink is operating, you don't have to deal with individuals. If you deal with individuals, they may complain that it's costly. But if you deal with the institutions, then it's not going to be costly. Probably we can talk about that one later, okay? Because Akwasi and maybe yourself will attest the fact that are you there? Oh, I thought you are.
Yes, we are here.
Oh, sorry. So Akwasi and maybe yourself, if not AC, will attest the fact that if you are to assign, if you have to connect internet for me to be used for a particular business and connect internet for University of Cape Coast to be used, you will see the difference. I will complain that it's costly, but the University of Cape Coast will not complain that it's costly because University of Cape Coast has more than 20,000, 30,000 students and workers. Even lecturers alone, we are more than 900. So all of us are going to depend on the same, signal. So it depends upon how you do the business before you can say that it's costly or depend upon the individuals who complain that it's costly.
Sorry, Doc. I don't mean to cut you off. I think you're referring to the bandwidth. Because even with me, whenever I work with a vendor, I tell them the specific bandwidth that I want.
Yeah.
So the larger the amount, the more bandwidth they will use, and the cheaper it is.
Yeah.
But I could see if I may be very sure, like Doctor, if I may ask. As for what I know with one Starlink device, as in when you set up, I know the maximum number of people you can hook up onto is about 200. That is per the information I have. So obviously, if you're looking at, more than 1,000 people, you're looking at different small satellites at specific locations. So probably you have one hostel that is having Starlink working for them, and someone is taking the internet money. Yeah, so if you're probably considering a group of people, you might probably say, okay, cheaper because everyone is paying. But if you are considering probably just one person and probably just a business with about 6 people, you know how Africans behave. Every initial cost hits us. Am I going to pay like 6,000 or 5,000 cedis for an internet? You know, we hardly have that attitude of considering the long term. Okay, I'm going to pay 100 cedis each for 5 years. We hardly do that. We always look at, am I going to dish out 5,000 or 6,000 cedis at the initial cost? So these are some of the little issues we might probably face. But as I said, it's sort of the best internet that we probably would be dealing with now. The larger the number, as you said, if you have about 200 people hooked on or 150 people hooked on who are paying maybe 10 cedis every month for it, for the speeds, or 20 cedis each month for it, which is put inside. I think it's obviously it's sort of the best sort of option you could get now, depending as in with regards to all the advantages that comes with it. That as per the information I have, you're looking at about 200 people for one installation. That's what I'm looking at. Maybe if there's any other information that maybe.
Okay, Quincy, I think if you want to conclude this issue today, it will not be possible because there are so many ways of doing it. Okay, there are so many ways of doing it. Even recently, DSTV, what do you call it, came to University of Cape Coast that they are going to connect some number of lectures together. Okay. So it's like the money that individuals have to pay reduce.
Exactly.
You put 5 people together, 5 people together, 5 people together. So there are ways of doing those things. Okay. And also, apart from the reliability of the signal, education has to go on. Okay. Before you operate in that business, you need to be able to educate the public about the what do you call it, the products. Okay, so I think a lot of things have to go in before we can conclude this issue. But in any way, no, I think Starlink and any other satellites that provide internet is better compared to that of the
far better. So we are just hoping everything goes through.
Now we are in the era of talking about internet and the Starlink. Assuming if there is any broadcasting satellite providing also other information via our televisions and then other things, also the multi-choice people are going to fight.
Of course.
You understand? Assuming if today I said that I have a company that can also give you a signal via satellite, a reliable one where you can watch football even on your phone and then other things. I also need what do you call it, the authority from NCA. And multi-choice will not sit down for me to just sweep through just like that, you know. So there are politics in all these kind of things. But like I said, every journey of 1,000 miles begins with a step. You have to get experts to talk about it. And I also understand the politics of you keeping mute for a while. Yeah, because it's like my mother used to tell us that Dencham nu chunsu amonu chunwe we are kasa dencham one or anasa one son. And yes, Anna said, wouldn't do suffering in our car. The crocodile is going to put you in the water, and you know, maybe you are not a good swimmer like me, so that will be your end. So I really understand, but let's move on.
I don't think I think there's provision for that. I mean, I do security too on the side, and the management platform, it only gives you about 25 licenses. But because my company is expanding, the next thing they are looking at is SD-WAN. That's the software-defined wide area network. And with that, we go into the cloud. So I think there's provision for that. If the company is expanding or there's more users in Ghana, I think there's that cloud technology that is possible for you to expand and get more users. Another thing too, I mean, also in a group of Ghanaians in Canada and America, it's like a WhatsApp group of about more than 2,000 people. So I think if we can get this thing out there, I mean, to push, to tell, I mean, people, to educate other people that, hey, this is what is going on in Ghana. I mean, Starlink needs to come to Ghana and it's going to help and stuff. At least that also helps. So maybe I may have to reach out to you guys after to get your contact, and maybe you can probably get this thing going, because until we speak, our government won't do anything about it.
Yeah.
Sure. Okay. Thanks,
Well,
Akwesi. And apart from that, too, you can also let them know aerospace is going. A lot of people don't even believe there is an aerospace something going on in Ghana. It's quite amazing. So,
but if I may ask, you know, all our media stations, they don't have any time to educate people about space technology and then other things. When you talk about space in Ghana, people all think about the moon, the skies, or somebody going into space and then other things. My university student, I sometimes ask them about International Space Station, and they don't know anything about International Space Station, you know. So it's like having a media attention to is another way to go.
But dog, these days, social media even sells more than media attention.
Yeah.
People are making good money on social media. So I think that's where we need to focus more on.
So like I said, if you are to carry a camera to individuals to interview them, because if you get more experts to speak to it, if you are talking in public, we will not criticize government straight, because we want to educate the public. So when you educate the public will rather start what? Agitating. Okay? And as experts, we will know how to tune issues. And at a point in time, you will see that they can't stand. If Ghana was able to move from what do you call it? Autocratic government to the democracy that is still killing us, then we can move from one generation to the other in technology as well. It starts from somewhere. How did a powerful man like former President Jerry John Rawlings came to understand that, okay, I will step down for us to vote before I become president again. And even after sitting there for 8 years, voting as a Democratic president for 8 years, he said, I will hand over to the next person. Every journey of 1,000 miles begins with a step. I was coming to speak Fanti. Like former President Rawlings, who have said that, no way, I'm not going to allow, nobody will have done anything about it. Yeah, about it. Nobody could have done anything about it. But as good as he is, or he was, he said, no, I'll be there for my country, for the future of my country, I will step down. And subsequently, President like Kufuor also accepted to, you know, give the baton to somebody. Even former President Mahama, he stayed for only 4 years. He was the chief of defense commander in Ghana Armed Forces. He could have said, no, I'm not allowing. I said, no, I will get down and then give it to somebody in that order. So look, we start from somewhere and we can gear towards, I mean, the achievement that we want to. Okay, so I will urge Galaxy not to give up, but bring the knowledgeable minds together to digest issues a little by little, and we will get there someday soon.
All right, sir. Thank you so much, Doc. Thank you for the words of encouragement and motivation. Let me put it that way. All right. So our time is a bit fast spent. I don't know, audience, if you have any other question. If not, then we progress to the next stage. Please, is there any other question from the audience?
Please, they
or
don't
contribution? Okay. Okay. So I would like to find out this last thing. I mean, we are talking about satellite technology. So before we close this section, I would like to know how satellite-based observatories are being used to monitor celestial bodies and the universe in general.
Come again.
So let's say, yes, well, let's say if a satellite is sent to space,
Yeah.
in the outer space, wherever, how is it able to give us the signal? Like, what process does it use?
Okay, thank you very much. Every satellite has what you call, a satellite itself is a system. And the satellite comprises of what you call subsystems. So one of the subsystems is power subsystem. That is in charge of giving the satellite power. So if you look at the wings of the satellite, it's full of solar panels, okay, connected to the power system that gives the satellite power. We also have what we call attitude determination and control subsystem. This subsystem also makes sure that the satellite is exactly in its orbit and it's not moving closer or away. It moves exactly with the orbit. We also have what we call communication subsystem. The communication subsystem also gives information out. And then we also have another subsystem called structure subsystem. That one is more mechanical. Let me not explain. And we also have what we call telemetry and command subsystem. The telemetry and command subsystem is the system that is able to communicate with any station on Earth. Okay, so wherever the satellite is, like Mars rover is in Mars, so but it communicates to the system on Earth. Okay, that is why GPS and then other things, we have various stations, various receiving stations. If you go to University of Energy and Allied Sciences in Sunyani, Yunnan, we have a satellite ground station there that receives many information from the satellite. Okay, for example, cosmic satellite in the whole Africa is only Yunnan in Ghana here, and then that of the Mauritius that has the downlink that the satellite offload information to. So the satellite comprises of so many subsystems, and each subsystem does things different. Okay, so the telemetry and communication system is there to communicate with every system on the Earth, and all these things are done and simulated before the satellite is launched to test, make sure that it is working before the satellite is launched. Though that doesn't mean the satellite cannot fail, but these things are done.
Okay, sir. Okay.
So in this thing, let me come in. One person does not build satellite. One engineer does not build satellite.
Okay.
Yeah, each and every engineer has a particular subsystem that he or she will work on. And then after that, everything is put together. Okay, as one system.
All right. So talking about each engineering putting things together, what causes a failure of a satellite?
Yeah, so the failure of satellite, they are in categories. Sometimes during the launching, the satellite will fail. The rocket can blast, or some of the variables, especially within the Earth atmosphere, can even destroy the whole system if critical study is not done before launching the satellite. But normally what fails the satellite, one is the power system. If the power system fails, there's no communication between the satellite and then the systems on the Earth, because it might not have power to do that. Okay, so even from the surface of the Earth or wherever they are launching the satellite to the orbit, there should be a power, you can say the power that can, the system in it that can give the satellite power till it gets there and then spread its, what do you call it, wings, where the solar panel and then other things are there. So if it's kind of engineering errors and then others, the satellite can fail. Also, if the satellite encounter unfamiliar environment that is not prepared for, the satellite can fail, which means a particular subsystem will fail. If you remember, in about 4 years' time, Indian Space Agency, they call them ISRO,
Yeah.
they launched a satellite, Chandra, is it Chandra or Chandrayaan?
Chandrayaan.
Chandrayaan, very good. Good one there. I met them in Spain and I met them also in Azerbaijan. That was last year. So the satellite failed. It failed. That doesn't mean the satellite is bent. The satellite is there. There's NASA satellite that is able to view the satellite roaming, okay, because it's at the moon. So it's roaming there, but it's not giving any information back to the systems on Earth, which means the communication system has what? Failed.
Yeah.
So if the satellite is keeping on moving, it means the power system is working, okay? And other systems are working, but the communication system is not working. Also, there are other satellites that will fail right from the beginning. Brazil launched a satellite. And during the launching, it burst and the 7 engineers, they all died. It also happened, European agency produced a satellite. It took so many years for them to produce. During the launching, it failed. So it depends. If a particular subsystem failed, it will not work. For example, NECOMSAT-1 in Nigeria, I learned it was a power subsystem. And if the power subsystem fails, you are not going to get any signal, though the satellite will be a debris, okay, a waste in the space, but it will not communicate. So it means before you even launch a satellite, there are some critical conditions that you have to take place.